right, guys, here we go. Here's the answer to the bell work. If you guys look, we have a one-step equation. Excuse me, if you would. You guys agree that we already have 1x. We have one of the three terms involved in the original problem already has 1x involved. So obviously the only thing that we have to get rid of it is a negative 17. And by doing that, we got rid of it by using its opposite, or positive 17, or adding 17 to both sides. And that makes x equal 10, and then I checked it below. Any questions on the bell work? No? All right, let's grade our homework and let's see how you did. Let's do this.
No.
You ready? What's in here? All right, x is 4.
Are we going down or by number order?
Let's go down. Is that cool? We'll go by odds, then we'll go evens.
Yeah.
Gotcha. Number 3, x is negative 1. Number 5, x is 24. 7, x is negative 3. 9, x is 6. 11, x is 2. 13, x is 25. And then 15, x is 2. Number 2, evens. X is 9. 4, x is negative 6. 6, x is negative 30. Number 8, x is 14. 10, x is negative 8. 12, x is 11. 14, x is negative 7. Number 16, x is equal to negative 17.
First try.
Number 5, x is 24. 4 and 9. Any questions? Ethan? Oh, you got a riddle or something?
Talk, darn it.
What?
Well, I have yesterday's homework, but as long as I can't find any late passes, so.
I know, I didn't give you one. Just put oops at the top. You're good.
Oh, good.
Oh, that's cool.
I did not give you guys who passes this quarter save a tree.
Yeah.
All right, so let's get started here. Let's put our homework off to the side. I'll collect it in a moment after we're done with the lesson. Huh?
Oops.
Oops, I did it again. I gave you my heart. And I don't know the rest.
All doing that.
And Emma,
What do you want me to do? I did.
you guys are going to grade it in just a second after I get through the lesson, so keep it. So put your homework off to the side. I'm going to do the lesson. We're going to actually take what we've done in the last, 3 or 4 days, and actually put the 2 different types of legal moves, is what hands-on would call it, or the 2 different types of steps that you would do in order to get x by itself. So we began our process of equations with one step, getting rid of addition and subtraction, correct? And we created 0 pairs. Isn't that that's what we first did. So when you look at these legal moves, this is the second check is really what we've done so far. Have we multiplied or divided the same number on each side of the equation? Yeah, we've divided. Didn't we divide by a number? Yes. Divide by 9 on both sides. Divide by 3 on both sides. Divide by negative 1 on both sides. We did that last night. Okay, so what we're going to do is take those 2 moves, or those 2, they call it legal moves and hands-on equations, but I would say operations, or steps, and those 2 steps will get us to x, or x by itself. All right, so the other legal moves, you're going to add throughout your equation experience, but these are all the different types of legal moves that you're going to see in 7th and 8th grade as you go through equations. All right, so if you look at the first problem, we're going to solve this equation. Now, right now, I hope everyone can identify 3 terms. If you notice, 3 terms again are involved. And what the purpose is that you guys, can you all find a term that has X in it? Can someone raise their hand and share with us so we all know we're all thinking the same term? Which one has the X in it, Hannah? 9X. So what we're going to do is I use something, I do this just for visual purposes. If you would, please just do this until we feel comfortable not having to do it. But I want you to box that term. I use that box to kind of, it's like a shield or a barrier, which means that you cannot do anything to 9X. You have to leave 9X alone. Leave it alone, okay? And what we have to do is we have to get 9X, that box, by itself before we can get 1X, because right now we have 9X's in that box, don't we? Okay? Before we can get that 9 or turn that 9 into 1 like we did yesterday, we have to get that 9X all by itself. So we have to make this problem look like a problem we did yesterday. All right? So I want you guys to focus in on that box, okay, and look at, do you guys agree that there's another term on that same side? And what our goal is we have to get rid of that term first. So what term is on the same side with the box, or the 9X? What's the same on the same side? Gates?
Negative 36.
Negative 36. Now, we began doing this. The first equations I had you do is we got rid of negative numbers, didn't we? And what do we put with a negative number in order to get rid of a negative number? A positive. So what we're first going to do, just like you did, the first equations I ever assigned you, is we're going to create 0 pairs. Every single time. So is that, when we box this variable, guys, I want you guys to understand that that box is kind of, you can't, it's like kind of protected. You cannot do anything to that box. So we're going to take, and we're going to add 36 both sides. So we're going to create the 0 pair first. And my board is a little slow. There, see how it's coming. It's a little slow. It's a little cold outside, I guess. So you guys agree right now, this positive 36 with this negative 36 makes that negative 36 go oof, gone. And now don't we just have 9X left over? So that's our first goal, is to get the term with the variable by itself first. That's the first step. All right? And that's using 0 pairs. That's how we do that. Use 0 pairs, so we're ultimately getting this by itself. So this goes bye-bye. And now we bring our 9X down. Whatever's inside the box, we now can bring down. Okay? What does 9X is equal? When we put 72 and 36 together, what's our new value? What does that 9X equal, Francis?
108.
Nice. Now I want you guys to look at this problem right here. Does this problem look familiar?
Yes.
Does it look familiar now?
No.
It should, because I could have given you this problem in your homework last night. Because what operation is left? What's 9X? Multiplication. And how do we undo multiplication, Renee? Division. So can anyone tell us, how are we going to turn this 9X into 1X? Because isn't that what we want? We don't want the value of 9X's. That's not going to help us. So Rachel, how are we going to make that 9 turn into a 1? Well, we're going to divide 9 by 9 first. Because isn't 9 divided by 9 1? And then we're going to do that same thing because we have to keep our equation balanced. Okay, we don't want any off lean. It would hurt your back. Those things to the spinal cord.
Gangsta drivers.
Okay, yeah, we don't want any of that. All right, so we got 1X here. So we bring our X down, bring our equal sign down. And what's 108 divided by 9? So what does 1X actually equal in this case? Alex? 12. Now, are we done?
Nope.
Absolutely not. Remember, our last thing is always checking. Our checks are going to help us determine if we're right, if our answer's right. I'm going to tell you guys, if you don't utilize these checks, this is where most kids decide that, you know what, they're not purposeful until they figure out that, oh my gosh, they actually can help us. Get 100% on every single assignment. Okay? The thing is until you make that mistake and that check helps you figure out that you've made a mistake, you might not see the purpose in checking. But right now, realize you're going to make a mistake. You're human. If you continue to check, you're going to catch yourself before you wreck yourself. You know what I mean? All right? So we got 9, and we're going to put our X involved, right? We're X inside the parentheses. And then we're going to subtract that 36, and that must be equal to 72. So x, we're going to plug 12 in. And now, look up here. If you guys put your hand over equals 72, look at the left-hand side. Doesn't it look like a GEMS kind of problem that maybe you've seen and you've done the funnel? So what you're going to do on this side, where you have the variable term and another term, you're going to actually do the funnel method. Another skill you already have. You've practiced that how many times? All right? So look at that side. We have multiplication and we have subtraction. So what are we going to do first? Think of GEMS. Think of the order of operations. What would we always do first, Jen? Absolutely, always. So 9 times 12 is 108. We're going to bring our negative 36 down. And obviously this funnel on this side has to equal what?
72.
Yeah, we have to make sure that it equals 72. So is 108 minus 36 72?
Yes.
Sure about that? 8 minus 6, 2. 10 minus 7 is 72. Indeed.
It's a miracle.
Well, you did it with me, so hopefully we got that right. Now, do you see how putting these two steps, we're kind of making the zero pair, then we're dividing, gets x by itself. Because there's two operations visible from the get-go, we have to use two operations to get to x. Does that make sense? If you have two operations, you have to get rid of two operations. That would take 2 steps. All right. All right, let's try another one. Again, you see 2 boxes? Can someone share with us what are we going to box this time? Emma?
Positive 8p.
Yes. All right, so we got positive 8p. Can someone share with us, how are we going to get that 8p by itself? How are you going to do that? Because we got to get the box. We boxed 8p, which means that's the variable term. So the variable term has to be by itself first. And then, so what are we going to do, Malia? Oh, it just went like that? Went crazy? It did that last hour, too. I don't know what's going on.
Cray cray.
Oh gosh.
You mean
What?
crazy. Cray cray all over here. You mean crazy.
All right, so let's do this. How are we going to get 8p by itself? What are we going to do to both sides? What are we going to do? Renee? Add 4. Do you guys agree that if we add 4 to this term right here, that term would disappear?
Yes.
And that's what we want. We don't want it there. All right? We want this box to be by itself, or the 8p. The reason why I box also, guys, sooner or later, you're going to have more than one variable term. Okay? And I use boxes for a visual to help you just understand the process. Sooner or later, you guys not going to have to box anymore, but for right now, just box, just for visual purposes, and maybe it'll help you along. So we're going to get rid of that negative 4. What's our left-hand side of our equation equal to? What's this side, left side? You know? 48. So our left side is 48. Ethan, do you have a question, or are you going to tell me what's on this side?
I have a question.
Yo.
Okay, that boxing thing, once you forget to do that on our homework.
I'm not going to mark it wrong.
Okay.
I just want you to use it in your notes as often as possible. If you do it on your homework, that would be great too. It's just because, you know, sooner or later you're going to have boxes on both sides. Or you're going to have, or variable terms on both sides. If we're going to box, I'm going to show you, you know, and then you have boxes on the same side. What do we have to do? So it just helps visualize those variable terms that are involved, where your variable shows up, because sometimes your variable will show up more than just in one term. Okay, it might be multiple terms that the variable is involved in. Okay, Ethan? Yeah, what does this side equal now?
8p.
8p, good. So you guys agree, once we get rid of this term, we have the box or the variable term by itself. Now again, we're at a point where you guys all should look at this problem and go, oh, hello, we've done this. Okay, we know how to do this from here. We did it last night. So,
Like
hello.
totally.
Huh?
Like totally.
Yeah.
Yeah,
So,
let's text about it. You mean totally.
isn't it like totes my goats or something? Is that how you do it? Isn't that totes my goats? Is that totem what?
You tote goats.
But isn't that totes is like totally? Is this because you guys are all mathematicians and you want like a shortcut to totally? Because mathematicians, you know, we've always, you know how they do abbreviations and we do shortcuts.
Actually,
And scientists, yeah. So you guys are
Totes McGee.
in disguise. So, what are we gonna do on both sides? We're gonna divide. Focus. Back into before I totes Magochi out of here. All right. So, Abby. Good. So we want P. We want 1P. So we have to make 8 turn into 1. So we're gonna divide it by itself.
Very good.
So now, if you guys look at this, we're gonna we have 1P here. And what does P equal? What is P gonna equal? Ethan?
6.
There you go. All right. So let's go over here. Let's solve. Let's check what we solved for x4, which, come on. There we go. So again, remember, look. The right-hand side of this equation is kind of like a gems, all right? So we should check it. Make sure you're checking it. So if we look over here, are we going to add or multiply first?
Multiply.
Multiply. So what's 8 times 6?
48.
Thank you, Nate.
What?
I wonder about some of you. Kind of.
Definitely not.
Me in general?
Only for a second, then I'm back to. All right. So solve. Put these two terms together. A -4 and a positive 48. Is it for sure 44? Well, we have 48 positive, so our answer is going to be positive. Okay, Nate, focus. And if you have this, we have -4, so they're different signs. We have more positives. The difference of their absolute values is 44. So it checks. I'd like you guys right now to do the next one by yourself, and then I will do it. Box your variable term, and be careful of your signs.
Guys, calm down.
Sorry.
Hey, Dylan and Nate, seriously.
Jennifer, here's your copy. What? What?
Keith is talking back.
No, I just said that your paper didn't have anything on it, but it was right next to yours, so it was yours. Your checks, remember, you did one thing, your checks in one piece, and then you did your work in the other.
I put my name on it? No.
It's right with your stuff, it's fine.
Okay.
Oh, big girl.
And big girls don't cry.
Correct. I cry if I want to, though. It's my party.
Alright,
now, you know that song, right? It's
My party. I want to cry if I want to.
Alright, so, if you guys look on the right-hand side, could someone give me that, if you put a -13 with a -7, what do you get? This is where all of you right now need to stop and look at what you put versus what I put. I already see you guys made the same mistakes as the previous two classes. So Emma, what did you put?
-120.
Think. If you put a -113 with a -7, are those same signs or different signs? Same. They're the same sign. So you add them together. But what's their common sign?
Yes.
Negative. So Emma is correct. So when you guys look at this, think of a chipboard. If I put 113 negatives on the chipboard, I put 7 more negatives. What is the only sign you see on your chipboard? What's the only sign? Negatives, yeah. So you'd be counting negatives. So think about that. How is that going to affect our problem? A lot. Because our answer is going to be affected. Okay? So now from here, would someone like to share? What do you do from here? How do you turn this into 1H? Emma?
You divide it by itself.
Mm-hmm. And we have 1H is equal to, but think, what is that answer going to be? Is it going to be positive or negative now? It's going to be negative. Because we have one negative. This one doesn't have a partner, so it's negative. What's 120 divided by 8, Anna? 15. See, if that's not negative, watch. If I left it positive 15, that would have been 120, right? Plus 7. Is 120 plus 7 negative 113? I sure hope not. So in order for that to all be true on each side, this has to be negative, that's negative. So now we have, yes, I agree that we're 113 more than the negative when we put the positive 7 with that. Because those 7 positives are going to hook with those 7 negatives. Yeah. Yep. Checks out. So, what I want you to do, I want you to try the first 6 on the homework that I'm going to pass out. Those people that still have to correct their homework from yesterday, the answer key is coming around, all right? I think Jennifer has it, Nate needs it, and then Ethan needs it, right?
I need it too.
And Emma needs it. So once it comes over here, you guys both can correct it once, okay? So,
Hannah needs it too.
oh my goodness gracious.
Ethan needs
Jiminy
it.
Cricket. Wait,
Were you here yesterday?
I was here, but I didn't do it. Can I give one to Kaylee, please? I mean, I forgot. I did actually.
All right, I need to stop this.